Thank you. It should be sounding something here. I think it's a problem with the sound. OK, let's start again. Let's start over. There we go. OK, well, welcome everyone. This session is going to be focused on artificial vision. Let me introduce myself first. I'm David Lopez, and I work as project manager and senior consultant within the artificial vision department at Midside. And during this session, I would like to introduce you three main topics here. First of all, I would like to introduce you how we treat an image so we can extract useful information from it. So we'll see how a computer is able to see the world, OK? The second topic will be the main challenges that we face in our daily work, so how we face it and why is that a challenge. And finally, I would like to prove you how artificial vision is a future technology by introducing you some real use cases on project where we have applied computer vision and artificial intelligence to solve a real problematic. So let's go. Well, that's a raccoon. That's going to be my first example, OK? I think it's funny. So I took this example to just prove you how a computer is able to see the world. As you have seen in the last video, a computer is able not only to recognize a raccoon in the image in the video, but it's also able to track this raccoon. And that's something that we can see nowadays, and it's pretty common. We've seen it with cars, with people, etc. But how is that possible? What do we have to do to an image in order to teach the computer to learn that that's the object we are willing to track? So let's continue with the raccoon. That's a raccoon we have in front of a door. And we like to know how computer sees that raccoon. Okay? First of all, the first thing we have to do is just apply some filters. So from the real image, the next image we'll have something like that. So as you've seen, the shape of the raccoon start to become in the front, and we can distinguish it from the background. If we continuously apply more and more filters, it's going to be clearer. Here we can group somehow the pixels, because an image is just a bunch of pixels altogether. But here, it's, I will say, clearer that the raccoon is in the front of the image, and we can distinguish from the background. This will be like final image for the computer, so every single pixel can be grouped together. And and you can see more or less that you have there the raccoon is more clearer than before. At the end, what we will have is a semantic segmentation. So we can distinguish, the computer will know where the raccoon is and what's not the raccoon, what's something of the background. This is something that we have already, okay? That's not big news here. It's something that we do currently, and it's pretty common. So how is that possible? What do we use in order to do that? First of all, we'll need mainly 3 things. The first of all, that is not included in the slide, but something that you need to have is the experience to know what an image is, how it will react when you apply certain technology or when you select certain capture devices, as I'm presenting now, like how it will affect to your process. Here, the capture devices that you select, it can be anything. It can be a drone, it can be a scanner if you are just digitalizing the documentation, it can be webcams, it can be HD cameras. And just to give you an example, last year, I went to surgery and I get my eyes corrected because my vision wasn't perfect, as it is now. But when I was a child, I didn't like to wear glasses, because I didn't. Even so, it was possible for me to recognize my friends. What does it mean? That means that even if we are not using the latest camera, latest fancy camera, we can do things. We can recognize objects. Even so, additionally, it might be better for us to select worse capture devices than the latest one. Under certain circumstances, for example, I was capable to recognize my friends better than my others, because it was in the night, and I don't used to see the faces, but I used to recognize certain patterns, like the way they walk, the way they wear. So depending on the project, you will select some capture devices or others. So once you have captured the image, the next thing you have to do is process it. If you work with data science and you know what a variable is, you need to know that an image that is a bunch of pixels, every single pixel means a variable. So in one single image, probably you will have thousands of variables that you need to control. So that's the reason, because we will require special processing hardware as well, depending on what we want. It might be just recognizing some faces, only one face in the image, so maybe a Raspberry, it's going to be enough. But if we are willing to recognize a lot of faces in real time, with a large point of view, probably we'll need to require a better server. And the last thing we need is the technology. Again, it's all about of your experience about applying technology, what will decide the success or the failure of the project. So if you know that certain technology will work, that's something you have to test. You don't know beforehand. But sometimes you will require neural networks, sometimes you will only require computer vision algorithms. It's dependent on the project again. So okay, coming back to the raccoon. As I said, it's not a big deal to recognize that that's a raccoon. That was clear, right? It's not neither a big problem to recognize the arms of the raccoon, not even the stone that it's holding. So what's the challenge here? The challenge is to know what the raccoon wants, to make a decision with that input. So what's your decision? Your decision might be grab a stick and go against it. Probably that's a bad decision. Maybe it's your pet, so you only need to have some food and put on it before the raccoon breaks your crystal door. Again, the challenge is contextualize the information you are generating. That's something that we'll see along all the presentation, okay? Contextualize the information to know more than the image is telling you. That was cool. Actually, I think about do the same dance, but bad idea. Well, again, the problem is not to track, it's not to identify the people. This video was presented 1 year ago, I think on yeah, more than 1 year ago on a computer vision conference. And then what they proved that they were able to track a lot of people in real time. So today, the problem don't used to be to extract the information from the image. The challenge will be to know what those people are doing. Are they fighting? Are they dancing? That's the challenge. That's something how we exploit all the information in real world. So again, of course, the better input you have, the better decision you can make. That's for sure. So now we don't have only a skeleton. We can have the matrix of a person, so you can recognize better where the hands are, the pose they have, etc., etc., etc. Again, to improve your input will always improve your output, but that's not the challenge. Okay. So, coming again, we prove we are able to track people. We prove we are able to track objects. Probably we are able to track and to know the speed of the train. So what do we have to do with this part of the video? The interesting thing, again, is contextualize all the information, is to know if the person is looking the train that is coming, if we have a person just running against the train, so we need to send a signal to the train. Maybe there is someone blind. We can detect that there is someone blind going just to the train, and the train is not making any noise. We could send that kind of information so we can make a decision here. So this is Shibuya Street. This is Shibuya Cross in Tokyo. Here, again, we prove that we can identify under certain circumstances that there is a problem, so we can react consequently. Again, it's not the problem to track the people, it's not the problem to track the cars, but to identify that there are people on the road while there should be another way around, and to identify, for example, if a car is stopped in the middle of the road because there was an accident. That's what we call contextualized information. So it's not only extract the information, but what to do with that information. I think actually, yeah. So, OK, that was theory. There was videos. But going to real use cases, I would like to prove how we solve real scenarios. And the first one I'd like to challenge you with is elections. OK, we work with the Dominican Republic elections. So what they propose to us is to recognize maybe a small, well, more or less. What you have over there is a real ballot box, a ballot paper in Dominican elections. And what they wanted us to do is to recognize the votes. And I say the votes, not the marks, the votes that we have on every single ballot paper. You can imagine that you cannot fail. Of course, it's an election, so we have a 99.9999999%, 99.9999999% of accuracy. So it's not all about, because there are some people, they tell me that computer vision is not accurate sometimes, that you miss something. It's always depend of the project and how you face it. I'd like to introduce, we have like 3 main variables over there, environment, hardware, and accuracy, and it will give you an idea of the project, OK? So what's the thing? Here, accuracy was almost 100%. We need to track every single ballot paper, every single mark, every single vote. So what do we have? What we did? So we narrow the rest of the variables. We narrow the environment, and we narrowed the hardware we use it. In this example, we use the same scanner for every single ballot paper, and we narrow the environment. That might be the print of every ballot paper. So we were capable of doing so. So the project was, firstly, we digitalize everything. Then we identify any possible mark. And at the end, we recognize the votes. And that might be easy, but it was a color ballot paper with black marks that they use in marker. So it's kind of incredible. I don't know if you are able to see where the mark is. Probably you recognize that the mark is on number 4, right? No, it's on number 16, right? So that might be easy. But if I continue moving on, where is it? On the 4th, because I told you in advance. But where is it? On the 9. That's true. But that was easy for you. Can you teach the computer to recognize black over black? And to do it, you need to do it with 99.999% of accuracy. That was incredible. I almost cried when we did it. Because it was a real challenge. Okay, let's go for another project. Industry. Industry, what we have to do here is take a decision in real life, in real time. Okay, and we need to be accurate, because if we dismiss a piece, it might be problematic for the company. So here, in the project that we were in charge of reviewing the production of rear view mirror. Concretely, we were reviewing the paint that they use in the mirrors. So what we decided is, again, we had to narrow the scenario because we were requested to have an accuracy, nice accuracy. So what we decided is to send an image, a light for every single mirror. And if you have over there the dot, that was a bubble. That was a bubble in the mirror, but we can detect any kind of scratch, any kind of defect, mostly. And we do it in real time, okay? The only thing we have to do is insert another step in the production of the mirrors, but we assure that that car, not only the mirror, but that complete car is not going to be turning back at the end. No client will tell me that, look, I don't like this car, this whole car, because you have a bubble in the mirror. So we save money, and we save time, and we have a better user experience for the clients. That's another good project. What they told us is you have to be able to detect these fissures, the smaller, not only the bigger one, but the smallest one. And that's a small fissure, but that's also considered a fissure. You see the dots, right? But you are going to use only webcams. There is no big camera here. You have to use webcams because we want this project to be cheap. So not always going to be the most expensive project, but sometimes we can do really accurate projects with really cheap devices. And that was an example. So again, until this moment, I've proved you that we can be accurate, and there is no need to use the latest camera, okay? We can also integrate with your current cameras, depend on what you want to do. But imagine the possibilities. The possibility will be in industry, in retail. Nowadays, we are capable to recognize every single object that we have in a shelf. And what's the problem here? The problem is that you cannot narrow the scenario as we did before. So you need to keep certain kind of accuracy, but the environment is going to be continuously changing. You cannot even control the hardware. So you need to ensure that the picture you will take, you will be able to process it, so you can extract all the products. And what's the purpose of it? The purpose of it is not to know what products are on the shelf, but maybe to go with Amazon Go and contextualize that information. So it's not about, OK, now as I told you before, the problem wasn't to get the input, because you can do it now. But if you contextualize that information you have, that you have the people, you have the products, you are able to do an Amazon Go now without censoring. You only need to have video camera. What can you do with that also? You can detect gestures. If you contextualize again the information and you know that a person is taking a product and put it on inside the jacket, you might consider it suspicious. So it's all about contextualizing the information. That's the challenge. So again, if we are able to detect the object that we see every day, and what we want to do is contextualize that information, imagine the next smart city. Next smart city might be with an image, with a video cameras that we have on every single street. We might be able to detect any kind of defect that we have on the roads. If you're using the buses cameras, you might detect that there is a hole in the road, so you can fix it. But how do you distinguish that hole than an amount, or how do you distinguish that a garbage, a trash is on the floor and not in the correct position? How do you distinguish that you have a graffiti and not a painting? That's what we refer with contextualize all the information, and that's something we do. That's something we are capable of doing now. That was funny as well. Here, I told you that to get the input using it shouldn't be the problem to get the input. It was a problem in elections because that's the thing, and that might be the problem here. We were requested to have a size, a measure of a warehouse, so we just send a drone on it. We just take some pictures, a two-dimensional picture with the drone. So we were requested to know how much grain, the percentage, more or less, how much grain does the client had in the warehouse. So what we did, again, send the drone, take some two-dimensional pictures, and rebuild, make a three-dimensional scenario. That's the thing you have over there. This way, the capabilities, it will help you to afford next cases, like to reconstruct an accident. So you send a drone to the road and just take a picture of everything, and then you can reconstruct the 3D dimension, so you can investigate and analyze what was the reason of the accident. That would be cool. That's something we are working on it now. And coming back, I introduced you this car accident, but with the car diagnostics, that's something we do currently. So the problem, again, is not to get the input, even so the environment is huge because you have a lot of different models of the cars, and maybe you are also willing to track or to recognize a motorcycle or any kind of object. So they request us to know if the car has any kind of defect. And depending on the project you have, the accuracy that you need might be different. So if you are on an onboarding process, probably the only thing you need to know is the car is okay, and that's it. If you didn't detect any defect, that was okay. You can go ahead and just sign the contract. But if you suffer an accident, that will be really useful for our clients, because if you know which part of the cars were damaged and how badly, it was really badly the car, and the part that were affected was not only the surface but the motors, you can tell in advance that you will have to replace these other pieces, and you will know beforehand how much money will it cost. So for us at Minsight, what we think we do correctly, what we think we do really, really nice is recognize object in the image, to analyze that image. And we do so because we have the capabilities. We learned how to do that from a lot of years ago, because we started with documents, but nowadays we are able to do two-dimensional analysis and three-dimensional analysis to recognize any kind of pattern. So even if we expose some projects here, the world of the computer vision and the artificial vision is huge. So you don't need to narrow your mind in those projects, but everything you can detect with your eyes, that's something that could be automated and teach a computer for that. Also, we have the experience to do so in any sector, as we work with public administration, we work with security, we work with car diagnostics and retails. And as we don't use any kind of product of the markets, we are capable of build our own solution and customize it in order to have the best solution in the market. So as conclusions, we really think that, artificial vision is a future technology, but it's currently in our days. That's something we don't see yet, but we will be talking about in the coming years. I know that that's difficult to understand, and that's difficult for the clients to trust us, because it seems kind of magic. But it's not magic, and we can prove it, and we have proved it with real projects. So we are glad to help our clients to digitalize all this kind of projects. Thank you. I don't know if you have any question. Anyway, you can contact me. I'll be just around here. It was super clear, so. Well, thank you, everyone. There's no question, right? Well, again, my name, David Lopez. You can contact me by the app, and we can chat everywhere. Thank you again.